So the definition of a logarithm, you can see there, the logarithm of number b on the base a is defined as an exponent and exists only at positive numbers. Log of the base, in brackets, of a logarithmic number b is equal to x. And so this is the exponent of a to the power of x is equal to b. Types of logarithms. So log a of b is, so that's the logarithm of number b on the base a. So a is always going to be greater than 0. A cannot equal to 1, and b is going to be greater than 0. Sometimes they won't give a base number there, and you would just assume it's 10 for a logarithm. So it would be log base 10 of b in brackets. And then there's ln. Ln is used more so after the first few classes of math because it's quite nice for a lot of formulas and a lot of graphs. So this is the natural logarithm, and it has a base of e. And if you guys have never seen e before, it's quite a fascinating function. Let's do y equals e to the power of x. You see its exponential growth that goes on till infinity. So yeah, it's quite a cool number. Also a constant, but if you put it to the power of x, it doesn't become a constant anymore, right? Log rules. So log of base a of 1 is equal to 0. And that's because if we were to go back to here, we have a to the power of x is equal to b. And so our a term is, I guess, a. Our b term is 1. So if we have a to the power of something is equal to 1, and anything to the power of 0 is equal to 1, right? If you had 10 to the power of 0, that's equal to 1, as seen right here. We have this rule as well. Log of base a of a is equal to 1. There's this one as well. When you have a logarithm like this, you can bring down that exponent of that number to the front of that logarithm, and that's equal to k. And then we have a to the power of log base a of x, and that one is equal to x. So when you have that base number as the first integer there, and then you raise it to the power of log of a, you get that as x in the brackets there. Product rule, you have log of a times xy. You can split that up into addition. So whenever you have things multiplying inside the brackets there, you can break them up and put a positive sign there. But the quotient rule is slightly different. When you have x divided by y, that is equal to log a of x minus log a of y. So you have a negative separating the two. So whatever's on the denominator of that fraction becomes a negative when you expand it out using the quotient rule. So log rules continued. We have the power rule, which we sort of saw already. The p becomes the integer at the front of that. Change of base rule, log a in brackets of x is equal to log base b of x divided by log b of a. And then the equality rule. So log a of x is equal to log a of y, then x equals y, obviously, right? Log to the base of a k, you can bring that k out and that becomes 1 over k, as long as k is not equal to 0, because when k equals 0, then that becomes something really disgusting, infinity, and it's non-existent. So don't do that. If k is equal to 0, don't do that. And then using log rules, we can find the exponent. So I'll let you guys take a look. So using log rules, try to find that exponent that makes that equation true. So if you have 6 to the power of a, we can use log rules. We can multiply both sides of that equation by log. So we see here that is true. If you do the log of both sides, they're both going to be equal still. So we do the log of both sides, we're almost there. And then we can use that rule, the power rule, where we bring the a down to in front of the logarithm, like that. The a becomes multiplied by the logarithm using a calculator, or that equation right there. And so that should come out to 5 as a. So if you plug that into your calculator using the logarithm function, and you divide it by that other logarithm. So it's the exact same for the other two there. Just for the sake of time, I won't do it. But instead of a, it's going to be b, and those other numbers will be switched around, right? But using that power rule, it's pretty useful to bring that down to the front. And then the last question here is simplify this equation. I would start off by first multiplying the 5 to every term here. So we'd have 10 log of x plus 15 log of 1 minus 25 log of 2. For this one here, log of 1, that's just going to be 0 because of the rule that we learned back here. And then since we do the opposite of what the log rule, or sorry, the power rule said, which was bring the exponent down, we can just bring that first number up. So if we multiply 5 by 2, we get 10. And we bring that exponent up to the x here, so x to the power of 10. Same for here. 5 times 5 is 25. We bring that up to the power 2 to the power of 25 here. And then using our quotient rule, we see that that's a negative in the middle, right? So we have log a of x minus log a of y. And it'd be the same thing for these two. And so in the end, you should have log of x to the power of 10 divided by 2 to the power of 25. And so log, all in brackets of that number, using these log rules here. A equals 5, B equals 6, and C equals 8. And then the final answer for that last one is log of x to the power of 10 divided by 2 to the power of 25. And then the last topic here is exponentials. So the product rule, if we have this exponent of this integer times this exponent of this integer, it's x plus y. If these two terms are multiplying each other, you would add up the exponents. So the quotient rule is a to the power of x divided by a to the power of y is just a to the power of x minus y. So this is the power rule. Now if we have a to the power of x multiplied to the power of y, pretty much being multiplied, do you combine them together? And then the power of a product rule, we can split this x to each of the powers of a and b here. And then 2 more slides here. Power of a fraction rule, we just do the same thing, a to the power of x and b to the power of x. The 0 exponent, a to the power of 0 is equal to 1. Anything to the power of 0 is equal to 1. And then the negative exponent, a to the power of negative x is equal to 1 over a to the x. So if you have a negative power, it becomes 1 over a to the x. And then the fractional exponent is as such. We have x as the numerator. That becomes the exponent of a. But then if it's divided by y, you have to do the root of y. And then simplify these. So the first one would be 5 plus 2, right? So x to the power of 7. This one, we have these in brackets to the power of 2. So using the sharing rule, we can do 2 to the power of 2, which is 4. But then we also have to do the same for x. So x to the power of 9 times 2. So x to the power of 18. So the final answer should be 4x to the power of 18. This is x to the power of 6 divided by x to the power of 2. So that's x to the power of 4. And then this one's to the power of 0. So obviously this is going to be 1. Anything to the power of 0 is equal to 1. For this one, this looks pretty complicated. You would have to take your time for this. We would first share the x across to each of these terms. So it'd be x cubed plus 3xy minus 2x to the power of 6. And then you would divide it by 2x to the power of 3. And this would be then subtracting from each of these terms that we just had. So if this was x to the power of 3, this would be 3 minus 3 is 0. And that would actually simplify to 1 in the end because we still have a number in front of that x. So the final answer should be 1 plus 3 times by y times by x to the power of negative 2 minus 2x to the power of 3. And that's all going to be divided by 8 because we did 3 to the power of that 2, and that becomes 8. And then the last one should be z to the power of 18, all divided by x to the power of 4 times by y to the power of 12.